Now that you've watched the video, take a moment to write down any questions so you can bring them to our next class. Always remember, you can watch the video again to deepen your understanding. If you enjoyed the video, please click like and subscribe. Today's lesson covers more trigonometric identities. Remember, we've been working through a few of these. These ones are called double angle identities. So double angle identities. Now let's take a look over here. I've written all the identities that we're going to use here for this lesson. I'll leave this spot on there, but you do want to get these into your notes. These are called double angle identities because sine 2 theta, there's my double angle, twice the angle. So I have 4 of those, and then I've put a couple more for reference just for our work today. So the first one is sine of 2 theta equals 2 sine theta cosine theta. Okay? Sine of 2 cosine theta equals 1 minus sine squared theta. Sine of 2 theta equals 2 cosine squared theta minus 1. And finally, cosine of 2 theta equals cosine squared theta minus sine squared theta. Now, we could derive all of those from first principles, but I'm going to skip that in this lesson because really the important thing is that you know how to use these. Now, I've also added for your reference, here's the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. And then as a reminder, because you will need to use this, tan theta is sine theta over cosine theta. Now, the way we use these is we substitute these things into other equations so that we can solve for certain trigonometric values, either angles or distances. And then I just want to remind you that these double angle identities are in your formula booklet right here. So you don't have to memorize them, but you should be very familiar with them so you can use them, and actually even so that you know that you can use them when you're looking at a trigonometric equation and you're going, what do I do? Remember, you've got some identities that will allow you to substitute and solve. Let's take a look at our first problem. Here are the givens. Given that sine theta equals 3/5, okay, so that's the value of sine theta. We're going to find exact values on this range from 0 to pi over 2. So pause the video for a sec. What is pi over 2? 90 degrees. So all of our answers are from 0 to 90 degrees. They're in the first quadrant. Okay, so all of our answers in this are going to be positive values. We'll need to do that when we take a look at the results of our calculations. Okay, first question. What is cosine theta? Remember, we're starting all these problems with sine theta equals 3/5. It's one of the deals on here, and actually, it's not one of the double angle identities yet. We're going to warm up with just using the Pythagorean identity. So go ahead, pause the video and solve that one. All right, here's how I did it. I put my, my plug-in step here. I just plugged in 3/5 for sine squared theta in my Pythagorean identity. So it's 3/5 squared plus cosine squared theta equals 1. I simplified. I did a lot of steps here just so you can see how I did. I squared my 3/5. I subtracted the square from the other side, got 16 over 25 for cosine squared theta, and then finally take the square root, and I have plus or minus 4/5. Now, the minus 4/5 value is not going to be in this range. That's going to be a negative value for cosine. It's going to be beyond pi over 2. So we only need the positive value for cosine theta, which is 4/5. All right, now let's get some practice using a double angle identity. So you're being asked now to find the sine of 2 theta. Now, you'll know that there's only one identity that deals with sine of 2 theta, so you know you're dealing with that one. It's going to want your sine theta and your cosine theta. So think back to the last problem. You're going to need to use that result. Now go ahead and pause the video and do your calculation. Okay, so let's check this out. First, I just wrote the equation with my identity from the top over there. Now I did my plug-in step. Sine of 2 theta equals 2 times sine theta. We get this from the setup on the problem. It's a given. So I have 2 times sine theta, which is 3/5, times cosine theta, which we know from the last problem we did was 4/5. Then I just did my math, and I have the sine of 2 theta is 24 over 25. All right, Now I want you to do cosine of 2 theta. Now this time you're going to have to take a look at the three identities that relate, the three double angle identities that relate to cosine. And the truth is, I think you can use any one of them. So go ahead, pick one and give it a try. All right, here's how I did that one. I picked the first identity. I just did 1 minus 2 sine squared theta. I did my plug-in step. I put in my 3/5 for my sine theta from the givens. I squared it. I multiplied it by 2. That gave me 18 over 25. Subtracted that from 1. I got 7 over 25. So cosine of 2 theta is 7 over 25. Now I want you to pause the video and pick a different one of these three and work that math, and you should get to the same result. All right, so I just went ahead and picked the second double angle formula for cosine, which is cosine of 2 theta equals 2 times cosine squared theta minus 1. I did my plug-in step. This time I'm plugging in my cosine value we found in the first problem. So I did 2 times 4/5 squared minus 1. I worked my math, combined my fractions, and lo and behold, I wound up with 7 over 25. So as long as you got that same result using the third cosine double angle identity, you're good. All right, this one's a little different. It's going to require you do a little bit of critical thinking and remember what tangent is, okay? So here's a double angle, right? Tangent of 2 theta. Now you have everything you need to know to analyze this problem and get a result. So I want you to pause the video and think about that one for a minute. Take it as far as you can. Let's see how you did. I'm going to do one step and then I'm going to have you finish it. So tangent of 2 theta is going to be sine of 2 theta over cosine of 2 theta. I'm using this identity. Now, if I've doubled the angle here, all I got to do is double the angle there and there, which is what I've done. So I've done the equation that I need. Now, I'd like you to pause the video and finish this up. Now, in case you were stumped, if you look back on the last 2 examples, you'll remember that we found the sine of 2 theta, which is 24 over 25, and we found the cosine of 2 theta, which is 7 over 25. So now all you have to do is plug these values into that equation and solve for tangent of 2 theta. All right, so here we did it. I just plugged in my 2 fractions. Now, if you recall, when you have a fraction divided by a fraction, you flip the bottom one and you multiply instead. So I have 24 over 25 times 25 over 7. Cross cancel the 25s, I get 24 over 7. So tan of 2 theta is 24 over 7. Okay, you're going to see a few other problems that force you to use the double angle theorems, like this one. So the prompt here is write as a single trigonometric ratio. Notice how we have 2 ratios in here. We have sine and cosine. So this one is kind of basically just a critical thinking step. There's not a lot of mathage going on. So take a look at your double angle identities and pause the video and write this as a single ratio. All right, if you weren't sure which ratio, I did that step for you. It's this first ratio here. That's the one that applies because we have 2 sine 4, cosine 4. So that fits that pattern. So if you haven't finished this one, now pause the video, use this ratio to write that as one ratio. Okay, so this is kind of basically sort of just a substitution. We have 2 sine theta cosine theta is the same as sine of 2 theta. Now we know that sine of theta is sine 4, so sine of 2 theta is just going to be sine 8. All right, try this one. And yes, this is a double angle identity type problem. So write this as one ratio. If you weren't sure which double angle identity to use, I gave it to you here. It's cosine 2 theta equals cosine squared theta minus sine squared theta. That's this one here from our reference. So now if you haven't finished this problem, go ahead and use this identity to write this expression as one ratio. All right, so this identity just allows us to take this expression and substitute into cosine 2 theta. So we got cosine theta is 0.3, so cosine 2 theta is going to be 0.6. So there's my answer for this one. Now that you've watched the video, take a moment to write down any questions so you can bring them to our next class. Always remember, you can watch the video again to deepen your understanding. If you enjoyed the video, please click like and subscribe.